dear student, welcome back in the class of engineering chemistry. I am Asha Pawar, working as assistant professor at SNJB's Let's Serve KBJ College of Engineering, Chandwad, Nasik. Student, today we are going to learn conductometric titration. So you know that the conductance is nothing but the reciprocal of resistance and its unit is per ohm. Okay, so if we increase or decrease the temperature, what are the effect of temperature on conductivity? So the conductance of solution increase with increase in temperature due to three different reasons. First one is increase the velocity of ions, decrease the viscosity of the medium, that is the water is the medium obviously during preparing the solutions for the measurement of conductance. So due to the increase in temperature, viscosity of the medium means water decreases. Decrease in the interaction between the ion, that is the cations and anion, that causes the conductivity. That interaction between the ions decreases because the velocity of ion increases and obviously interaction between them decreases. So the cell used for the measurement of conductance is known as the conductivity cell. The conductivity cell, that is nothing but the solution whose conductance is to be determined is placed in a special type of cell known as the conductivity cell. Means the solution whose conductance is to be determined or measured is placed in a special type of such a cell is known as the conductivity cell. So what is there in the conductivity cell? There are the two electrodes, that is the platinum electrodes are used that dip in the solution directly for that cell. For that solution we measure the conductance. Then here above this two platinum plate in a small glass tube, mercury in contact with the platinum. The cell is made up of from the glass, and there is directly the wires or copper wires can be used for the electrical contact. So the electrolytic solution can be taken in the beaker or in any type of glass jar, and directly we insert or place that two platinum electrode that contact with mercury in the electrolytic solution. So the distance between the the platinum plate is 1 centimeter. So the conductivity cell is used for the measurement of conductance. Then next one is how to determine the cell constant, that is the L upon A is a constant. L is a distance between the two electrode and A is a cross sectional area that electrode used for the measurement of conductance. So from the specific conductance we easily calculate the cell constant. So the specific conductance is equal to cell constant upon resistance. Then cell constant is equal to specific conductance into resistance, and if we take the reciprocal of 1 upon resistance is nothing but the observed conductance. So the cell constant is equal to specific conductance upon specific conductance upon observed conductance. Then conductometric titration, it is the most important part of the unit. Different types of acid-base conductometric titration included in syllabus. So what is the principle of conductometric titration? The principle involved is that the electrical conductance depend upon number and mobility of ion in the solution. That is, we done the conductometric titrations, that during that we measure the conductance with the help of the instrument known as the conductivity meter. Then the conductance is depend upon the number and mobility, that is the speed of the ion present in the electrolytic solution. So the first type of conductometric titration, that is the acid base, strong acid strong base conductometric titration, and very common strong acid used in the chemistry, that is HCl, and strong base, that is NaOH. So with the help of instrument, conductometer and conductivity cell, that is the two platinum electrodes required for the measurement of conductance, we can calculate the end point or equivalent point of the strong acid strong base conductometric titration, and from that equivalent point we calculate the strength of either acid or either base that is unknown to you. So how this conductometric titration can find out this equivalent point of the titration? So HCl is a strong acid, NaOH is strong base, means they both are completely ionized. Initially, if we take the HCl in a beaker or in a glass container and dip the conductivity cell, that is the platinum electrode, in that, and that platinum electrode we attach to the instrument, that is the conductivity meter. Then in burette we fill, suppose, the known concentration of NaOH. Then initially we observed that at the initial stage the conductance of this HCl is higher because it completely ionized, and obviously conductivity is depend upon the speed and size of the ion or mobility of the ion. So H plus is the smallest ion, that's why the conductance or mobility of this H plus is higher, that's why conductance also higher. That's why at the initial stage, that is in the diagram, at the A point, conductance is maximum because HCl is completely ionized, H plus is a very small size and highest mobility. As the addition of NaOH from the burette in HCl, what happens? This reaction takes place, that is higher mobility H plus ion is replaced by lower mobility Na plus ion, and that's why conductance decreases up to the equivalent point. Means at equivalent point all HCl converted or neutralizes into NaCl due to the addition of NaOH. That's why from A to B conductance decreases, and again we add excess NaOH from the burette, then conductance again increases because after equivalent point conductance of the solution due to Na plus and OH minus ion, and again it is a strong electrolyte. That's why from B to C conductance again increases, means in a strong acid strong base conductometric titration at equivalent point conductance is minimum, and at initial stage conductance is maximum.